And yesterday I had the chance also to spend some time at AIT with Professor Kanchana and her students, and it was a real pleasure for me to have this very precious time. So a lot has already been said today in the previous presentations and in the panels, and I might sound like a broken record to some of you, so apologies for that. Perhaps my presentation will give a more of an outsider view of the earthquake and the impact it had on networks, especially in Myanmar. No need to repeat what has already been said. The earthquake has created quite a lot of damage, especially in Myanmar. And we have seen pictures of data center infrastructure being damaged. So this is some information that I've collected from Broadcom about the power grid collapse. So obviously without electricity, people cannot have access to the internet. The servers will not function. Packets will not be sent from one place to another. So obviously no internet. But on top of that, there were many damage to telecom towers. We have seen 60% of towers in Sagaing and 45% of telecom towers in Mandalay that were torn down, and which means that more than 2 million people were disconnected from the internet. And also fiber optic cables, especially on the key routes along Yangon and Mandalay highway, which is a very key trajectory, basically, where a lot of fiber is laid. So I will show some slides later. Were also affected, for example, landslide, where cables were buried and broken, basically. So all of these contributed to the fact that a lot of people got disconnected, and obviously things take time to get repaired. And as our previous speakers mentioned, even if the core infrastructure were not damaged and were still functioning, the access network was really where the pain point was. So this is a cable map from the ITU showing the both submarine cables and terrestrial cables. The green dots are the landing points for Myanmar, and the red dots are also the what we can say the exit points of Myanmar towards other countries. So it's good because the country has multiple exit points. So in the case of, for example, a cable cut, there will be most likely other routes that can be taken inland to route the traffic, whether it is through Thailand or through China. There are other possibilities. So it's good to see redundancy at this level. That's a fun fact. So did you know that submarine cables could be used for as sensors for earthquake? And apparently the Myanmar earthquake was the first time where a large magnitude earthquake was detected using an array of telecommunication sensors on submarine cables. So that's probably new technologies that can be helpful in the future, especially detecting undersea earthquakes, which can result in tsunamis and different other types of disasters that can impact people and also telecommunication services. So we've seen this before. This is the where the earthquake happened, and the fault line. The dotted line in the middle is the fault line from Sagaing down to Yangon, and where the red is where the most severe, the most violent shaking happened. What if we overlay the network cable on top of that? So this is what I try to do, taking the terrestrial fiber cable. And what we see is that where the fault is, or where the most of the shaking happen, is also where there's a big concentration of internet cable. Those internet cable are key to the connectivity in Myanmar, because it connects to the cable landing stations, which are in the south of the country, and then allow connectivity back to the country. So it's a very important artery in Myanmar, and because the fault happened there, the most violent shaking happened there. Most likely, the cables were damaged as well. So this is data coming from a platform called IODA, which is Internet Outage Detection and Analysis. It's a platform which is managed by researchers at the Georgia Tech Institute in the US, and they were able to get some information through different means, and they were able to plot where were the most where were the outages, where did it happen. And as you can see, it was also following the same fault line and the same area where the most of the shaking happened due to the earthquake. And these are the different ASNs on the right that were mostly affected, starting with YTCL was the one that was the most affected during that time. So the platform collects data from three different main sources. One is from BGP. So BGP is a global routing table where operators will announce their prefixes. So it is seen by collectors around the world, and IODA has access to those collectors and can see changes in BGP. So the green line, the top green line, is whether there has been a change in the number of prefixes that is being announced by operators in Myanmar. And indeed, there was a change, not that big of a drop, but still there was a change in terms of the number of BGP or prefixes that were announced. And probably the cause is that the power outage, routers were no more connected, BGP sessions were dropped, and therefore prefixes were removed. But as you can see, it didn't drop to zero. It dropped to a certain level, maybe less. We got less than 10% of prefixes that were removed. In terms, then the second statistics that we can see is the blue line. The blue line is about active probing. So on the internet, so in that case in Myanmar, there are hosts that are pingable, so we can reach them from the outside. So IODA basically send pings constantly to those servers and try to see whether they are active. And as you can see, as the earthquake happened, there was a drop in the active probing. It means also that those hosts were not available anymore. So the reason why: infrastructure damage, power grid failure, etc. And the third one is about what we call internet background radiation. It's basically servers which are on the internet that they would send traffic to other places, and there would be collectors called network telescope that would capture those traffic. It's called background traffic, and this is what we see on the yellow line. We didn't see any major change on the network background traffic actually. So the two most places where we could see the change was in the active probing and in the number of prefixes that were announced. Cloudflare is another organization that also collects this data, and from their standpoint, they have seen a 17% drop of prefixes, IP prefixes that were being announced. And this more or less corroborates with what IOTA has also been saying. Cloudflare also provides traffic data. So this one is about HTTP traffic data. So as you know, Cloudflare have caches a little bit around the world. Not sure if they have a cache in Myanmar itself, but the cache could be the next hop away. So for the case of Myanmar, it's most likely in Singapore or Thailand. So they collect requests from users, for example, to connect to different websites that are hosted on Cloudflare. And based on the requests that they get, they can produce graph of traffic around the world. And indeed, they saw a 60% drop of traffic. Obviously, the reasons that we know already, people had no more access to the internet, but it was not the whole country was disconnected, obviously. Part of it, this is why you do not see a full drop of traffic, but partly a part drop of traffic. But that's not the case for all the networks in the country. So the first one, TMCL had a 20% drop of traffic. MCCL had a 60% drop of traffic. MPT had a 30% drop of traffic, and Ocean Wave had the biggest one actually. So it's probably the one that has been the most affected. We also can get some information from the Google Transparency Report. So the Google Transparency Report has a few information on, for example, the number of requests they are getting from YouTube, Google search, and a variety of services that Google is providing. And they provide this report publicly, and it's freely available to everyone that that is interested in this data. Actually, at the Internet Society, we use a lot this report to understand the changes that are happening around the world in terms of usage of services, but also we track what we call internet shutdowns. So these are usually intentional shutdowns of the internet for various reasons. And whenever there's a shutdown, we actually see a drop in the level of the demand, basically, of services. And Google being one of the most used services is usually a good proxy for showing changes due to some events that are happening. And we indeed see a 30% drop of traffic from Google. And so we also looked at the traffic graph for the Myanmar Internet Exchange, and the good thing, well, they have more than 40 members connected, which is good. So there's a lot of local traffic exchange in the country. Obviously, when the earthquake happened, due to the decrease in demand, we saw also a decrease in the number of in the amount of traffic that was going over the peering fabric. We have also seen that a couple of days later, things started to get back to normal. So this is good to see, and even we could see some burst on the graph, and I think this is due to networks getting connected, and when things start getting connected, you start seeing some bursts and some traffic spike, and this is showing like activities getting back to normal, and as you can see, now it's more or less the same as it was before. So it means that a lot of effort has been put in place to allow the networks to get back into place and connect back the people as well. So this is great to see. Another statistics that we looked at is also Measurement Lab. So Measurement Lab is a global platform that allows people to run speed tests. So if you, for example, if you're at your home, you want to test your bandwidth speed, you would go online and say speed test. So there are a few providers of speed test information, but this one is open to the public. So the data that they are collecting is freely available. So we looked at the bandwidth that people were experiencing at during the earthquake, before and after as well. And obviously before the earthquake, there were a lot of tests that were being carried out, and then a bit less during the earthquake. And then we started to see back to normal afterwards. So there was just a little dip in terms of bandwidth that was being seen and experienced by end users in the country, but things got back to normal quite immediately after. So we wanted also to see, because Thailand also got impacted to some extent by the earthquake, so we wanted to see whether there has been any change in terms of traffic demand. And interestingly, not so much. Things were quite stable, so there is no events that were seen really on the Cloudflare, at least on the Cloudflare traffic graphs. Obviously, we do not have more information like an ISP would have, and therefore we rely on publicly available information, for example, this one, and we could see that there were no real change in terms of traffic and for different ISPs in Thailand. Business was also as usual for the YouTube traffic using the Google Transparency Report. So in that case, also not so much change for Thailand. So it means that the internet, or at least the infrastructure, was not impacted by the earthquake, and people carried on their life as normal. Another place that we can also have publicly available information is again the routing table. So this is another project called RIS. So it's a route information system from the RIPE NCC. And similarly, as we have route views, which is another project collecting route information around the world. Route trees also have collectors that they collect route information, and indeed we have seen a dip in terms of the number of IPv4 and IPv6 prefixes being announced at some point for Myanmar. Again, that possibly related to the fact that there was a power outage, and possibly that network gears were pulled down because of the power outage. For Thailand, we haven't seen any change, and our conclusion remains the same. Then I tried to look at the routes. So the same platform, so Measurement Lab. Whenever you do a speed test, the platform, what it does a reverse trace route from the server. So usually the speed test the vantage point is your own computer, and the server is a distant host that is either hosted within the country or outside the country. The closest MLab server for Myanmar was in India, and therefore we could see the trace route from India to Myanmar again. And obviously before March, there were like we have seen there were like 10,000 tests that were carried out, and after the earthquake, the number of tests got reduced, and that's quite evident because the number of tests were reduced as well. People were no more testing because no more access to the internet. But what we have seen is that the route that it takes, for example, from India to Myanmar, it goes through Singapore, didn't change. So one would expect that in the event of an outage that the route might change. So for example, we have seen those changes when there are cable cuts, because a lot of international connectivity rely on international cables, submarine cables, but in that case there were no outage to submarine cables. So this is why we haven't seen any major change except on the number of samples that we could collect. There is at the Internet Society we have a project called Content Locality Tracker. So it comes from our vision that as much as possible, 50% of content should be hosted locally in a country. So there are many countries that have passed this 50% mark, but a lot of countries that are still lagging behind. And the Internet Society is putting a lot of effort in place, for example, to bring the content caches to the countries where there is not enough local content. And this goes in line with all the efforts that we are also putting in place for increasing, strengthening the local ecosystem, the local peering ecosystem. And as you know, we have been investing a lot in building infrastructure, building IXPs around the world, and hopefully to see impact such as this one. So Myanmar, unfortunately, most of the content is still hosted outside of the country due to a lack of hosting infrastructure. And obviously, they need international connectivity to have access to those content. So for example, most of the content in that case is hosted on Cloudflare, but Cloudflare is external to Myanmar, most likely in Singapore, and therefore they would need that international connectivity to reach those content. As I mentioned, there were no problems, no outages on the submarine cables. So as soon as connection were reestablished, they could reuse the submarine cables as such. We have seen cases, for example, in Africa, in West Africa and East Africa, where they had cable breaks due to fishing activities, and it took them quite a long time for them to repair those cables. So having three cables connected to Myanmar is good, but perhaps is not good enough, because if one or two cables goes down, there might be a bottleneck, and performance might be affected, etc. And it also depends on what is your upstream provisioning? How does it look like? Do you have access to different providers? Do you have capacity on different cables and access to different providers? Or do you concentrate everything in one provider? So not only you need to have access to multiple cables, but you also need to have access to multiple providers using both terrestrial routes and submarine cable routes. So this graph is showing, so we take the top 1,000 websites for each country, and we try to determine where who is hosting the content. So we can see that a lot of the content, the top 1,000 websites that are visited in Myanmar, are mostly hosted on Cloudflare. Some of them are hosted on local on native servers. Some of them are hosted on Amazon, Microsoft, Akamai, etc. And we try then to determine where the cache is. Is it local to the country or is it external to the country? So as you can see, a lot of the content is external to the country. And if we need to know where which country they will be hitting to get access to the content, yeah, so Singapore is like the most prominent one. They have a little bit of content in Myanmar itself, and the rest is from other places, including the US. So we have the same graph for Thailand, and I think this graph is looking a bit better. And we did the exact same exercise. We took the 1,000 most visited websites in Thailand and tried to determine where who is providing the content caching. As you can see, more than 600 websites are hosted on Cloudflare, and Cloudflare has a local cache in Thailand. So it means that when you access a website on Cloudflare, you are accessing a website which is local to you. So you are gaining a lot in terms of latency and performance, and you are also gaining a lot in terms of cost as well, because using local connectivity, especially for your IXP, means you rely less on international transit, and therefore it's better for your pockets. So the question we had is how resilient countries are against outages. It's quite a difficult question because earthquake, they are rather unpredictable, right? But someone before me mentioned that we need to be prepared. So the level of preparedness is actually quite important. So how do you get prepared? So you need to be able to measure things, to be able to see how things are evolving over time. And in that spirit, we have built a tool called the Internet Resilience Index at the Internet Society. So the Internet Resilience Index is quite of a mixed bag of different indicators that shows how good or how bad the internet is in a country. So we have broken it down into what we call pillars, pillars of resiliency. So the first one is about infrastructure, in which we look at fiber connectivity. We look at the number of exit points, international gateways. We look at the number of data centers and the number of IXPs in the country. So put together, we have some sense of how mature and resilient the infrastructure of a country is. We also look at performance, where we look at the stability of bandwidth over time. So whether it is upload speed or download speed, latency and jitter. So those indicators help us to know whether a network is performing well. Because you might have good coverage, but if you do not have enough bandwidth, maybe a lot of your application wouldn't be working. So it is an important criteria that needs to be factored in when we consider resilience. The next pillar is obviously security. Security is an important pillar because we need to know, for example, which are the networks that are adopting the best practices for security. Or is your network at risk of being, for example, of being hijacked? Or is your network putting other network at risk? As you know, the internet is based on what we call the tragedy of the commons. So if everyone is implementing security practices, it will just have the herd effect, and everyone will be more protected altogether. So we look at the different security technologies, for example, DNSSEC, and both the signature and the validation part. We look at routing security, we look at DDoS protection, etc. And finally, In this indicator, in this framework, we also have added a less technical feature, which is about the market. How mature is your market? Is it a market which is enabling, for example, competitivity, other players to come in? Is it a market which is closed, controlled? And we also have an indicator about diversity and also market competition. So put together, this framework allows us to get information about the state of resilience, or if you can call it the health of the internet in a country. And we can track this over time because we have been able to collect data from quite a number of years, from 2019. And we are able to track this, the evolution over time. So this is the graph or the chart that we get once we calculate the index for the countries. As you can see, the countries that are the most the more resilient are a lot based in Europe. The Scandinavian countries are actually topping the table, but we have in other regions, for example, Brazil, Argentina, Saudi Arabia, Australia, and Thailand, as you can see here, is seen as a quite resilient country. So if you go on pulse.internetsociety.org, which is our data platform, you go on the country report for Thailand. I was actually checking this morning, and a lot of the indicators are in the green zone, which means that this community has been putting a lot of effort to build a resilient network from the infrastructure to the performance, security, and market readiness things. You guys are ticking quite well in most of the boxes. So one thing that we looked at is also the outages. So the outage that happened, obviously, was it something that we could control? But there are outages that happen on a daily basis on the internet, and the reasons are varied. It can be a BGP hijack, it can be a DDoS attack, it can be, for many reasons, there might be outages. So what we try to do is we map the outages against the index. And what we have seen is that in most cases, there is a negative correlation between the index and the outages. So the more you increase your index of resilience, the less likely you will fall in the less likely you will have an outage. And the less your resilience is, the more likelihood that you might have an outage. So this shows that the data is speaking by itself. This shows that resilience is important to reduce the level of outages. Now let's talk a little bit about the recommendations. Obviously, we talk about that, right? Seismic, earthquake resilient. What we need to do, we need to implement, for example, seismic resistant design in telecom infrastructure. I think that's important. Maybe from the onset, we need to be able to build and design data centers, telecom towers that are earthquake proof. We need to put them elevated and put shock absorbing mounts for critical equipment in flood or quake prone areas. And also, we talked about that earlier, the risk assessment and also for the preparedness of the infrastructure is important. And I think not only for the infrastructure, but also for the people managing the infrastructure. Are they trained enough for them to quickly handle recovery actions after earthquake? I've put a picture of the sleeping Buddha, which has a crack, but I'm not sure whether this crack was just after the recent earthquake. But if the sleeping Buddha was on a shock absorbing stand, maybe they wouldn't have a crack. Okay, so what we should do, diversify our network routes. I think this is quite evident from what we have seen. The more diversity we have in terms of international connectivity, the better it is. So yes, continue building terrestrial cables, and yes, let's continue connecting to submarine cables as in many places as possible, to increase redundancy and reduce the likelihood of an outage. So cross-border peering and transit with neighboring countries is important. So usually this is a pain point in many countries. For example, me coming from Africa, we have a lot of issues between African countries where, for example, a landlocked country needs to have access to a seaborne country for international connectivity. The agreements are usually very difficult to put in place, but hopefully here in this region, with coordination and a more regional collaboration, things such as cross-border connectivity, hopefully is not too much of an issue. Redundancy of key infrastructure, of course, is important. So we shouldn't put all our eggs in the same basket. So as much as possible, distribute IXPs and critical infrastructure in multiple regions. Let's not put everything, let's say, in the capital city, for example. So if there is a bigger city and there is a need for an IXP, let's create an IXP over there and allow people in that region to get interconnected. The data centers as well should, as much as possible, not be all in the same place for things not to break at the same time. Whenever we have an earthquake or a disaster, we need emergency communication system. So we shouldn't turn a blind eye to maybe new technologies that are coming up, like LEOs. If possible, those could be helpful in time of trouble, and possibly maybe design our networks and design our emergency response in such a way that we can leverage those systems in the future. Obviously, redundancy is important, whether it is also for connectivity or for power outage. We have seen recently in Spain a big power outage that knocked off not only Spain but also Portugal, and it even had collateral effect in some African countries because they relied on Spain for international connectivity. So a problem with your power grid can affect the internet. The human network is obviously very important. We need people to be informed about the risk. We need people to be properly trained and prepared for responses. But this is also, I guess, this is what meetings like this one is trying to build, right? Like a relationship between people, and making sure that we know who to contact, and we have the cohesion that together we can bring back network as fast as possible. So natural disasters do not just break buildings. They also fracture connectivity. They deny people access to important information during this time of crisis. So it is important that the response time is as low as possible. Maybe one thing I would like to highlight, especially coming from the Internet Society. So it is important that the Internet remains open, globally connected, secure and trustworthy. And we would want to see less curtailing of Internet access in different countries. And especially in the time of a disaster, where Internet access is so important to people to connect and to be able to have access to the services and to connect to other people. So it is very important that Internet is not shut down, especially in the time of crisis. I wrote a piece about the Myanmar earthquake and how it was a crisis within an already existing crisis. It is on the Pulse platform. So pulse.internetsociety.org, which is our data dashboard. It contains quite a lot of information on different health indicators on the internet, and you can have a sense of how your country is doing in terms of internet resiliency. It also contains a lot of information, whether it is from the blogs or from the policy brief that we have written about many outages that happen and other recommendations that we have. I would like to thank you for your attention. I didn't use the full hour, but I think people will appreciate that we have a bit of time before lunch. Thank you.
Thank you very much, Amreesh, for a very clear picture on network resilience. I'd like to open the floor for questions, please. If anyone has a question, please raise your hand, and yeah, our member will go to you with a microphone. So over there, sir. Microphone for our, yes. Excellent.
Yeah, I'm Garapan. I'm from AIT. I see your recommendations, and I see you talking about the fiber optic under the sea, and there is no problem for this kind of cable for a very long time, even if there is an event of earthquake. So that tells us that if the infrastructure is under the ground, is safer than upper the ground. So there is no recommendations to, for example, build data center underground, under sea, whatever.
Well, that's a good observation. I think maybe if you have data centers under the sea, might be interesting for cooling purposes. But obviously there's a cost associated to that. So yeah, I have no recommendation for undersea data centers.
Thank you very much. Any other questions, please? Okay, well, thank you very much, Amreesh, once again.